Hello everyone, my name is Akash Patel and welcome to my presentation on AWS SageMaker Autopilot Studio and Experiments. This presentation is a part of my AWS Certified Machine Learning Associate course. So, as machine learning become more popular, building accurate model is become increasingly important. However, developing a good machine learning model usually required a lots of time and repeated experimentation. In today's presentation, we will learn how AWS SageMaker Autopilot automates model development, how SageMaker Studio provides one complete environment for machine learning projects, and how SageMaker experiments help organize and compare multiple training runs. By understanding this service, we can see how AWS makes machine learning development faster, easier, and more organized. So let's get started. So before we begin, let's take a quick look at what we will cover today. First, we will learn about AWS SageMaker Autopilot. So we will see how this AutoML service automatically prepare data, select suitable machine learning algorithms, tune hyperparameters, and build machine learning models with very little manual effort. Next, we will study the complete autopilot workflow. Starting with the dataset stored in Amazon S3, we will follow every step until train model is ready for deployment. After that, we will explore the different autopilot features and training modes. We will also discuss autopilot expandability and learn about SageMaker Clarify helps explain model predictions by showing which input features had the greatest influence on the final decision. Then we will move on the AWS SageMaker Studio, which provide one integrated environment for preparing data, training models, monitoring experiments, and managing machine learning resources. Finally, we will learn about AWS SageMaker Experiments, which help developer organize multiple training jobs, compare different models, track hyperparameters, and reduce successful results. So by the end of the presentation, you will understand how all of these AWS services work together to simplify the machine learning model deployment, development process, and help developers build accurate and reliable model more efficiently. So now let's understand why automated machine learning is so important. So building a machine learning model is much more than simply choosing an algorithm. A successful machine learning projects usually require many experiments before finding a model that perform well. O- As datasets become larger, the amount of work also increases. Sometimes hundreds of training jobs are required before finding the best performance performing model. Every one of these training jobs use AWS computing resources, which also increase the overall cost of the development. Because of this, it is often difficult to know which algorithm should be tested first. This is where automated machine learning or AutoML become valuable. Instead of performing all of these representative tasks manually, uh, AutoML automatically handle much of the work while still allowing developers to review, improve the final model. So AWS provide this capability through SageMaker Autopilot, which help developers build accurate machine learning model much faster while reducing manual efforts. So now let's look at more closely AWS SageMaker Autopilot. Autopilot is managed AutoML service that automatically perform many of the tasks required to build a machine learning models. Instead of manually preparing data, selecting algorithms, and tuning hyperparameters, the user only need to provide the datasets and choose the target columns that the model should predict. After receiving the dataset, Autopilot begin analyzing the data. Once all candidates' models have been evaluated, Autopilot recommends the model that performs the best. This allows developer to spend less time conf- configuring cloud resources and more time solving business problems. This notebook explain every steps that was performed and can be modified if additional customization is needed. So imagine a bank want to predict whether customers will reply their loans repay their loans. Instead of manually testing many different machine learning algorithms, the bank simply upload historical customer data into Amazon S3 and start SageMaker Autopilot. Autopilot automatically blue train and compares several models and uh, recommend the one that perform best for the prediction task. This saved both time and efforts while producing a reliable machine learning model. So now let's understand how SageMaker Autopilot performs all of these tasks automatically. The process begins after the training datasets has been uploaded into a Amazon S3 bucket. The users then identify the target columns that contains the value the model should learn to predict. After receiving this information, Autopilot examines the data sets and prepare it for machine learning. So during training, different hyperparameters value are tested to improve model performance while AWS manages all of the computing resources in the background. So when training is completed, Autopilot create a model labor board. So this labor board thanks all of ranks all of the trained models according to their evaluation results, making it easy to compare their performance. So developer can review every steps, understand how the model was created, make modification if necessary, and then deploy the selected model into production. So this structure workflow makes machine learning development simpler while still giving developers full visibility into the entire process. So let's look at some of the important features of SageMaker Autopilot and types of machine learning problems it can solve. One of the biggest advantage of SageMaker Autopilot is that it automates many difficult machine learning tasks without taking complete control away from the user. Although Autopilot prepare data, select algorithms, and tune models automatically, developers can still review the generated notebook, adjust settings, and customize the model whenever needed. Another advantage is the Autopilot reduce the amount of manual work required to build a machine learning model. So Autopilot can be used through the graphical interface in the SageMaker Studio or through the AWS SDK, making it useful for both beginners who prefer a visual interface and experienced developers who write code. The first is binary classification, where the model predicts one of two possible outcomes. For example, a banking system can predict whether a transaction is fraudulent or not fraudulent. The second is multi-class classification, where the model select one option from several categories. A good example is classifying customer reviews as positive, neutral, or negative. The third problem type is a regression, where the model predicts a continuous numerical value instead of selecting a category. Housing price prediction is a common example because the model estimates a selling price based on information like location, size, and the number of rooms. To solve the different problems, Autopilot automatically select the suitable algorithms such as linear learner, XGBoost, deep learning models, and assemble methods depending on the dataset. This flexibility allows developer to solve many different business problems without manually selecting algorithm every time. Every machine learning dataset is different. So because of this, using the same training strategy for every dataset does not allow always produce the best result. So the first option is hyperparameter optimization, often called HPO. In this mode, Autopilot selects one suitable machine learning algorithm and performs many training jobs while testing different hyperparameters value. Instead of accepting the first result, it continues researching until it finds a better performing model. The second option is assembling. Here, several machine learning models are trained independently and their predictions are combined into one final model. Since each model learns different patterns from the same dataset, combining their knowledge often produce better accuracy and more stable predictions. The third option is auto mode. Instead of asking the user to choose a training strategy, auto mode automatically decides where the hyperparameter optimization or assembling is more suitable for the dataset. This is especially helpful for users who are new to machine learning because they don't need to understand every optimization techniques before training a model. By providing these different training modes, SageMaker Autopilot improve both efficiency and model quality while reducing manual decision making. So let's now take a closer look at HPO, hyperparameter optimization. These training modes focus on improving the performance of a single machine learning algorithm. After selecting an appropriate algorithm, SageMaker Autopilot begins testing many different combinations of hyperparameter values. Hyperparameters are settings that control how a machine learning model runs during training. Example including the learning rate and maximum tree depth. These settings can have a major impact on predictions accuracy. Instead of manually changing this value, the retraining the model again and again, SageMaker Autopilot performs the search automatically. It can evaluate up to 100 different training trials to identify the best performing combination. So this method learn from previous training results and intelligently select the next hyperparameter value to test. For large data set, Autopilot use multi-fidelity fidelity optimization. Instead of spending the same amount of time on every training job, it focus more resources on the model showing the greatest potential while stopping poor performance model earlier. Instead of manually changing the learning rate dozens of times and a retraining after every adjustment, SageMaker Autopilot performs all of these experiments automatically and recommend the model that performs best. This saves both time and efforts while improving the model quality. So the next training mode is assembling. Unlike hyperparameter optimization, which improve one model, assembling combines several different models to produce one final predictions. The goal is to improve predictions accuracy by allowing multiple models to work together. In this mode, SageMaker Autopilot trains several machine learning models using the AutoGluon library. Each model learns different patterns from the same data sets. So stacking combines the outputs from several strong models to create one final predictions that is often more accurate than any single models. During the process, Autopilot performs 10 different training trials. So let's use the example from the slide. Imagine an online shopping company is building a product recommendation system. One model may learn customer buying behavior, another may recognize seasonal shopping trends, and third model uh, may identify similarity between product. So by combining all of these models, the recommendation system produce better suggestion than relying on only one mode. So although assembly requires more training time because several models are created, the improvement in predictions accuracy often makes it the better choice for many real world applications. So the final training mode is auto mode. Auto mode is designed for users who may not know which training strategy is best for the dataset. Instead of making the decision manually, SageMaker Autopilot analyzes the data before training begins. So if the dataset is larger than 100 megabyte, the Autopilot generally choose hyperparameter organization because it works efficiently with a larger workload. If the dataset is similar than 100 megabyte, Autopilot usually select assembling, since combining several models often produce better predictions accuracy or smaller dataset. These are also situations where Autopilot cannot accurately determine the data size. So, for example, if the dataset is stored in a restricted Amazon S3 location or uses certain manifest file configuration, Autopilot automatically falls back to hyperparameter optimization to ensure the training can continue successfully. So instead of worrying about which optimization strategy to select, developer can focus on preparing high quality data and solving business problems while AWS automatically choose the most appropriate training method. So now let's move to another important features called Autopilot expandability and with SageMaker Clarify. So, building an accurate machine learning model is important, but understanding why the model makes a prediction is just as important. In many real-world applications, users do not want only the final predictions; they also want to understand the reason behind the predictions. This is where SageMaker Clarify become useful. Uh, SageMaker Autopilot works together with SageMaker Clarify to explain how a trained machine learning model reaches its decision. Instead of behaving like a black box, the model become much easier to understand. Clarify measures the contribution of each input features by using SHAP, which stand for Shapley Shapley Additive Explanation. So this method is based on the concept of Shapley values, which uh, originally came from cooperative game theory. In simple words, every input feature is treated like a team member working together to produce a final predictions. SHAP calculate how much each feature contribute to the predictions. So, for example, imagine a bank use a machine learning model to decide whether a customer qualify for a loan. So instead of simply showing loan rejected, SageMaker Clarify can explain that the customer's low credit scores and high debt ratio had a greatest influence on the decision. So expandability is especially important in industries such as healthcare, finance, and insurance, where machine learning decisions directly affect people's life. By explaining how predictions are made, organizations can improve transparency, build user trust, and identify possible bias before deploying model into production. So next, let's learn about AWS SageMaker Studio. As machine learning projects become larger, developers often need many different tools for preparing a data, writing code, training model, monitoring results, and deploying applications. So SageMaker Studio solves this problem by providing one integrated environment where the entire machine learning workflow can be managed. In- Inside SageMaker Studio, developer can prepare say, data set, write Python notebook, launch training jobs, perform hyperparameter tuning, monitor experiments, and deploy trained models. So having all of these capabilities in one place makes the development process much more organized and efficient. Another advantage is that SageMaker Studio work closely with services such as SageMaker Autopilot, SageMaker Experiments, and SageMaker Clarify and Model Monitor. So let's consider the example. So imagine a data scientist build a cell forecasting model for a retail company. Instead of opening separate application for data preparation, model training, and result analysis, the entire project can be completed inside SageMaker Studio. This centralized workspace improves productivity, reduce project complexity, and make collaboration much easier. So now let's discuss AWS SageMaker experiments. Building one machine learning model is rarely enough for solving real-world problems. Data scientists usually train many different models, test several algorithms, and try different hyperparameters value before finding the best solution. Without proper organization, it's become difficult to remember which experiment produced the best results. SageMaker experiments solve this problem by automatically recording important information about every training jobs. This include the data set that was used, the selected algorithms, hyperparameters value, evaluation metrics, and overall model performance. Instead of relying on memory or handwritten notes, every experiment is stored and can be reviewed whether needed. If one experiment reduces uh, excellent results, the same configuration can easily be repeated later because all of the important settings have already been saved. So, for example, engineer may train dozens of different models one several weeks over several weeks. So later, they may want to identify which experiment produced the highest recommendation accuracy. Instead of training every model again. SageMaker experiments uh, allows them to review previous results, compare performance, and produce the successful model quickly. As machine learning projects become more complex experiments tracking becomes essential for improving organization, saving development times, and supporting teamwork. So before we finish, let's review the main ideas for from today's presentation. So we learned AWS SageMaker Autopilot automate important machine learning tasks such as data preparation, algorithm selection, hyperparameter tuning, and model evaluation. So we also learned about the complete Autopilot workflow, which start with the data set stored in Amazon S3, train multiple candidates models, ranks them using a model labor board, and provide a notebook that developers can review before deployment. Uh, hy- Next is autopilot training mode. Hyperparameter organization improve one model by testing different parameter combination. Assembly combines several model to improve prediction accuracy. Auto mode automatically select the most appropriate training strategies based on the dataset. We also saw the SageMaker Clarify improves model transparency by explaining how predictions uh, are made and identify the features that have the greatest influence on the final decision. Finally, we learned SageMaker Studio provide one centralized environment for machine learning deployment, while SageMaker experiments keep every training runs organized so successful model can be compared, reproduced, and improved more easily. Together, these AWS services make machine learning deployment faster, more organized, and more efficient. So this brings us the end of my presentation. Today we explored is AWS SageMaker Autopilot simplify machine learning by automating model development, how SageMaker Studio provide one integrated environment for building and managing machine learning projects, and how SageMaker experiments help organize and compare training runs. I hope this presentation has helped you better understand how these AWS services work together to build efficient, accurate, and scalable machine learning solution for real-world application. I would like to express my sincere gratitude to my professor, Dr. Govinda Swami, for his continuous guidance, encouragement, and support throughout my learning journey. His practical teaching has helped me strengthen my understanding of AWS cloud technologies, machine learning concepts, and their real-world applications. So, thank you so much for watching this presentation. Have a wonderful day, and please like, share, and subscribe for more AWS machine learning content. Thank you.